Welcome. Today, we are going to do something a little crazy. We're going to try and explain, well, all of math in a way that actually makes sense. So let's just dive right in. Okay, so have you ever looked at something like this and your brain just shuts down, right? It feels like you're trying to decode some secret alien language. Well, I promise you are not alone. But what if I told you that all of this crazy-looking stuff is actually built on just a few incredibly simple ideas? That's right, it really does all start with a number. That's it, just a simple symbol that stands for an amount of something. Everything in math, and I mean everything, from counting on your fingers to launching rockets, it all begins right here. So let's think of this next part as learning the alphabet of math. Once you know the letters, you can start making words and then sentences. It's way more straightforward than you might think. So here are our letters, the core pieces. We've got our numbers, which we know. Then there are constants, which are really just numbers that don't change. Then you have variables, those letters like X or Y that are basically just placeholders for a number we don't know yet. And finally, operations. Those are just the instructions, right? Add, subtract, multiply, divide. That's the whole toolkit. And when you take all those building blocks and put them together, you get an equation. Now, the best way to think about an equation isn't it some scary problem. Just think of it as a puzzle. Your job is to find the missing piece. Okay, so how do we actually solve these puzzles? This brings us right to the heart of algebra, which is really all about one thing, finding the value of that unknown, that mysterious x. And the strategy is actually kind of beautiful in how simple it is. The goal is always to get that variable all by itself on one side of the equal sign. So how do we do it? You just use the opposite or inverse operation to peel everything else away. If a number's being added, you subtract it. If it's multiplied, you divide it. It's all just a game of balance and undoing. Now, not all puzzles look the same, right? You've got your simple linear equations, which have one nice, clean solution. But then you get into things called polynomial equations. That's where the variable can be raised to a power. And here's the interesting part. These can have more than one solution. The puzzle gets a little trickier. So what's the trick for these harder puzzles? Well, the secret weapon is something called factoring. It's basically the art of taking a big, scary-looking equation and just breaking it down into smaller, bite-sized chunks that are way easier to solve one at a time. All right, enough with the abstract x's and y's for a minute. Let's talk about something we can actually see and touch. This next section is all about geometry, which is just a fancy way of saying we're using math to describe the shapes, space, and angles of the real world. At its core, geometry is all about measuring two main things. First, you have area, which tells you the size of a flat surface, like the amount of carpet you need for a room. Then you have volume, which tells you how much space is inside a 3D object, like how much coffee fits in your mug. And look, the basic formulas are really similar. So about 2,500 years ago, this Greek dude named Pythagoras basically walked up and said this, before dropping one of the most legendary ideas in the history of math. And his theorem is just so elegantly simple. It says that for any triangle with a perfect 90-degree corner, if you square the two shorter sides, we'll call them A and B, they will always add up to equal the square of the longest side, C. It's like this magical hidden connection between the sides of every single right-angle triangle in the universe. So, if Pythagoras gave us this awesome relationship between the sides, what about the angles? Well, that's where trigonometry comes into play. It's literally the study of how a triangle's angles and its side lengths are connected. They have this fixed, predictable relationship, which means if you know one, you can figure out the other. Okay, so we've covered static numbers and fixed shapes. But what about a world that's always in motion? Things that grow, that move, that change. This is where we get to calculus, which is simply the mathematics of change. Now, the absolute bedrock of calculus is an idea called a function. And don't let the name scare you. A function is just a rule. You give it an input, we call it x. The rule does something to it, and it spits out a specific output, which we call y. That's it. Input, rule, output. So if you have a function, you can pretty easily find the average change between two different points. But calculus asks a much cooler and much harder question. How fast is something changing at one single instantaneous moment? What's the speed right now? And the answer to that question is called the derivative. The idea behind it is just pure genius. If you take any curve and you zoom in on it like way in,
Eventually, it starts to look like a perfectly straight line. The derivative is just the slope of that teeny tiny little line. It's the rate of change in a single instant. Now, let's flip to the other side of calculus. What if you wanted to find the exact area of this weird, curvy shape? There's no simple formula for that. So what do? Well, the calculus way is to slice it up. You chop it into a whole bunch of tiny, easy-to-measure rectangles. And this brilliant idea leads us to the integral. An integral is the amazing tool that lets us add up the areas of an infinite number of those impossibly thin little slices. And by doing that, we can find the exact, perfect total area under any curve you can imagine. It's the ultimate adding up machine. So we've gone from algebra puzzles to the calculus of change. But how does all this thinking help us in the real, unpredictable world? Well, let's talk about one of the most practical parts of math, probability, or the mathematics of chance. The basic idea here couldn't be simpler. To figure out the probability of something happening, you just take the number of ways it can happen the way you want, and you divide that by the total number of things that could possibly happen. So with a coin toss, there's 1 heads you want out of 2 total sides, which gives you a 1 in 2 or 50% chance. And really, all of probability is built on 3 super simple rules. First, a probability is always going to be a number between 0, meaning it's impossible, and 1, meaning it's absolutely certain to happen. Second, if you add up the chances of every single thing that could happen, the total is always 1, which of course leads to the third rule. The probability of something happening plus the probability of it not happening has to equal 1. So after all of this, let's circle back to where we started. We've seen that from basic counting all the way to the wild ideas in calculus, everything is built on logical, step-by-step ideas that anyone can understand, which really just leaves us with one last question. Is math some scary secret code we should be afraid of? Or is it just the beautiful and elegant language that we use to describe the universe?